Now we are going to learn about vanishing and exploding gradient in context of activation functions. Vanishing and exploding gradient are used a lot in deep learning, and people raise this as a common issue and something that we need to address too. But vanishing and exploding gradient can have different meanings in different contexts. In activation, it has one context which we are going to talk about now. In the next chapter in LSTM, it has a different context in terms of the way memories are learned in LSTM. So we'll get to there when we are there. Now let's learn about this for activations. So in the previous part, we learned about how the activation gradient comes into play while we are learning the model. We saw that when we differentiate the loss function, we get the activation gradient here. By the way, I missed a 2 here. 2 does not really matter for our discussion, but still. So in this we have this gradient term, and I'm going to write it down here. So I brought this expression here, and I'm writing it in short that my gradient of loss is proportional to the activation gradient for this last layer. But here, if you look at Z2, Z2 is also a function of my prior weights. Let's see how Z2 looks like. Z2 is output of this layer. The input to this layer is Z1. Therefore, Z2 is Z2 is dot product of the input that is getting into this, its weight, and added with the bias term and surrounded by an activation on this layer denoted by G. When I plug this expression, the expression for Z2 in here, we'll get a longer expression. Let me write it down. So when I replaced the term for Z2, the Z2 here with what I'm expressing there, like this. And when you derive this further, you can refer it to the chapter in the book. This B2 part gets out, and this ultimately becomes proportional to product of these two gradient terms. First is the gradient of my activation on the output layer, and the second term is the gradient of the activation on this hidden layer. So for this hidden layer, we had to add another gradient term. And now I'm going to go a step further because we have another hidden layer, and Z1, which we have here, this Z1 is basically coming as an output of this layer. Z1 is expressed as Z1 being the output of my first hidden layer is actually a function of the observations we have, the input samples X. Upon substituting the Z1 here with this expression, which contains my actual observations X, I get this final expression for the gradient of loss, which has 3 terms, and you can see that these 3 terms are because we have 3 hidden layers here, including the output layer. So what we are learning here is, for every layer we are going to add to our network, our gradient terms will become bigger. For every layer we will have an additional term in this gradient. Now the problem that it brings is we have three gradient terms being multiplied, and if their values are unbounded, meaning if they can take any value from minus infinity to plus infinity, this can become a large number, it can easily explode. When you multiply numbers which are large, they increase exponentially. And if we have even more layers here, the likelihood of this exploding in that case becomes even higher. And that is what we call as exploding gradient issue. Now, exploding gradient issue was there, but people found some workaround that by capping the value of gradient if it was becoming too large, simple thresholding. That would work somewhat, but a bigger problem was the vanishing gradient, which we cannot solve by having such workarounds. Just like a chain product, a chain multiplication can explode if their values are large, they can exponentially diminish and get close to zero when their values are small. If all of them are small numbers, for example 0.1, if you multiply 0.1 3 times, you get 10 to the power minus 3, which is practically zero. So, depending on the behavior of the gradient, if the gradients can take small values, the gradient of an activation can take small values, our overall gradient of loss can quickly vanish, and that would make my model parameter updation very feeble, and it severely affects the model training. So that was about vanishing and exploding gradient in context of activation function.